terraforming. It's a word that evokes science fiction, a vision of humanity reaching out to reshape worlds beyond our own. Terraforming is the process of transforming a hostile alien environment into one suitable for life. It's about taking a planet like Mars, cold, barren, and unforgiving, and turning it into a second home for humanity. Mars, our red neighbor, has captivated our imaginations for centuries. It's a planet of stark beauty, with towering volcanoes, vast canyons, and polar ice caps. But beneath this alien allure lies a harsh reality. Liquid water, essential for life, is scarce, locked away as ice beneath the surface. Yet, amidst these challenges, the dream of terraforming Mars persists. Scientists and engineers envision a future where we might engineer the Martian climate. It's a daunting task, but the potential rewards are immense. Terraforming Mars is not just about creating a backup planet for humanity. It's about pushing the boundaries of our knowledge and testing the limits of our technology. Mars is a planet gasping for air. Its atmosphere, 100 times thinner than Earth's, clings to the surface like a tattered shroud. This thin air, composed mostly of carbon dioxide, offers little protection from the harsh radiation of space. To make Mars habitable, we must first give it air to breathe. This means thickening the atmosphere and changing its composition. One ambitious proposal involves releasing trapped greenhouse gases from the Martian soil and polar caps. These gases, like carbon dioxide and methane, would trap heat from the sun, warming the planet and thickening the atmosphere. Another approach focuses on importing volatiles, elements and compounds with low boiling points from elsewhere in the solar system. Comets and asteroids, rich in water ice and other volatiles, could be carefully redirected to impact Mars, releasing their precious cargo into the atmosphere. These are monumental tasks, requiring technologies far beyond our current capabilities. Yet, they illustrate the audacity of the terraforming dream, the belief that we might one day wield the power to reshape entire planets. Mars is a planet in deep freeze. Its average surface temperature is -63 degrees Celsius, too cold for liquid water or life. To warm Mars, we need to trap more of the sun's energy. One idea is giant orbital mirrors to reflect sunlight onto Mars. These mirrors would focus the sun's rays, warming the planet. Another approach is darkening the surface to absorb more heat. Spreading dark material could warm the planet gradually. These ideas show the creativity needed to make Mars habitable. While a thicker atmosphere and a warmer climate are crucial, they are not enough to make Mars truly habitable for humans. We need oxygen, the lifeblood of our planet, to breathe and thrive. Creating a breathable atmosphere on Mars is perhaps the greatest challenge of terraforming. One promising avenue involves harnessing the power of nature itself. Photosynthetic organisms, like algae and bacteria, could be introduced to the Martian surface. These microbes, bathed in sunlight, would convert carbon dioxide in the atmosphere into oxygen, gradually transforming the Martian air into something more breathable. Another approach involves building massive industrial facilities powered by solar or nuclear energy to extract oxygen from Martian rocks and soil. These facilities, operating on a planetary scale, would slowly but surely increase the concentration of oxygen in the atmosphere. Creating a breathable atmosphere on Mars is a multi-generational project, a testament to the patience and perseverance of the human spirit. It's a challenge that will require the combined efforts of scientists, engineers, and dreamers from all walks of life. Section 5. The invisible threat. Shielding Mars from radiation. Mars, stripped of its protective magnetic field, is bombarded by harmful radiation from space. This radiation, constantly showering the surface, poses a significant threat to any life we might introduce. To make Mars a safe haven for life, We must find ways to shield it from this invisible menace. One solution involves creating an artificial magnetic field around the planet. This could be achieved by building a network of superconducting rings around the Martian equator, generating a magnetic field that would deflect incoming radiation. Another approach focuses on building radiation-resistant habitats and structures on the Martian surface. These structures, constructed from thick layers of Martian regolith or other shielding materials, would provide a safe haven from the harsh radiation environment. Protecting life on Mars from radiation is a complex and challenging endeavour. It requires pushing the boundaries of our technological prowess and understanding of the universe. Yet, it is a necessary step in transforming Mars into a world where life can flourish. Section 6. Water, water everywhere. Creating Martian oceans and rivers. Mars, once thought to be a dry, desolate world, holds the promise of water. Vast reserves of water ice lie buried beneath the surface, remnants of a wetter, warmer past. Unlocking these ancient stores is key to creating a truly habitable Mars. One ambitious proposal involves detonating nuclear weapons near the Martian poles. This controversial idea aims to vaporize the polar ice caps, releasing vast quantities of water vapor into the atmosphere. This water vapor would then condense and fall as rain, filling ancient Martian riverbeds and creating new lakes and oceans. Another, less dramatic approach focuses on using solar or geothermal energy to melt the subsurface ice. This water could then be pumped to the surface, slowly but surely irrigating the Martian soil and creating oases of life in the barren landscape. Water is the elixir of life, and its presence would transform Mars from a dusty, red world into a vibrant blue planet teeming with possibilities. Section 7. A Time of Giants. The long road to a habitable Mars. Terraforming Mars is not a task for the faint of heart. It's a multi-generational project, a testament to the long-term vision and commitment of countless individuals working towards a common goal. The timescale for terraforming Mars is vast, measured in centuries or even millennia. Scientists estimate that it might take hundreds of years to thicken the Martian atmosphere and warm the planet sufficiently to support liquid water. Creating a breathable atmosphere and establishing a stable biosphere could take even longer, perhaps thousands of years. These timescales are daunting, but they also offer a sense of perspective. Terraforming Mars is not about instant gratification, but about laying the foundation for a future far beyond our own lifetimes. It's about planting the seeds of a new world, nurturing them with our ingenuity and perseverance, and leaving a legacy that will inspire generations to come. Section 8. A Cosmic Dilemma. The ethics of terraforming. The prospect of terraforming Mars raises profound ethical questions. Do we, as humans, have the right to reshape an entire planet to suit our needs? What if Mars harbors its own forms of life, microscopic and hidden, but no less deserving of protection? Some argue that we have a moral obligation to use our technology to make the universe more hospitable to life, even if it means altering existing environments. Others caution against tampering with the natural order, arguing that we should focus on protecting and preserving life on our own planet before venturing to remake others. The ethical debate surrounding terraforming is complex and multifaceted. It requires careful consideration of our values, our responsibilities, and the potential consequences of our actions on a planetary scale. Section 9. A Martian Future. Dreams of a red-green world. The dream of terraforming Mars is a powerful one. It speaks to our innate desire to explore, to discover, to create. It's a vision of a future where humanity becomes a multiplanetary species, expanding its reach beyond Earth and establishing a lasting presence among the stars. Imagine a terraformed Mars, a world of verdant forests, sparkling oceans, and bustling cities beneath a salmon-colored sky. Imagine children playing in Martian parks, scientists studying alien life in Martian seas, explorers venturing into the uncharted territories of a new world. While the challenges of terraforming Mars are immense, so too are the potential rewards. Terraforming Mars is not just about transforming a planet. It's about transforming ourselves, about pushing the boundaries of human ingenuity and creating a future worthy of our dreams.